Microstrip antennas are one of the most popular antennas in the wireless communication market, and we can find applications of microstrip antennas in various fields of the high-tech technology, like in mobile communication, in our cellular phone, in satellite communication, either in fixed antennas or fixed application or mobile application, missile telemetry, biomedical uses, or radar systems. Microstrip antennas received considerable attention starting in the 1970s in a paper written by Robert Munson, and although the idea of microstrip antenna can be traced back to Deschamps back in 1953. The major advantages which makes the microstrip antenna so popular are they are low weight, low cost, low profile, and they can fit any shape, therefore they are conformal. Microstrip antennas are also very easy to fabricate and can be integrated with other microstrip components in monolithic application like RFIC or MMIC. However, they have also some drawbacks. The drawbacks which I'm going to talk about are initially when the microstrip antenna have started to be present in the market, but some of them have been minimized dramatically. The major drawback of a microstrip antenna is its low frequency bandwidth, and the reason for the low frequency bandwidth of the microstrip antenna is actually because of their physical basic concept, which is based on a resonator type. These drawbacks actually have been minimized in the recent years, and we can obtain, as we'll see later on in the presentation, even microstrip antennas which can cover even 70 to 80%. When I'm talking here about low frequency bandwidth, we are talking about 4 to 5% bandwidth. Another drawback is their relatively low radiation efficiency as we go up in frequency, or when the antenna array size increases. And this is due to the increase in the feeding network losses, which increase as the lengths of the feeding lines increase, and also with the frequency. Again, this kind of drawback can be traced back to the initial design of microstrip antennas, but in recent years also significant breakthrough have been done also on this drawback, and we can see today designs with based on waveguides or hybrid waveguide and microstrip lines or parallel plate waveguides in which the network losses have been minimized dramatically, and we can obtain high efficiencies even at very high frequencies up to 30 or 40 gigahertz. Another drawback of the microstrip antennas is that they're relatively low power levels that they can confine because there is a danger of breakthrough between the patch antenna and the ground, and therefore they cannot fit very well for application like high power radars in which we try to transmit kilowatts or megawatts. So we are talking here about an antenna which can operate very well in the hundreds of watts and a little bit above, but not very high power.